Good morning, students. This is Maithili, Assistant Professor from Department of Mathematics. Last class, we saw some definitions in differential equations, homogeneous functions, homogeneous equations, and variable separable method. And also, we saw some problems in homogeneous equation. Today's class, we are going to see the same method homogeneous equations problems. Today's class also we are going to see the same homogeneous equation problems. See the first problem. Solve x cube plus y cube into dx minus xy square dy is equal to 0. This is a given equation. We have to solve the equation. Solution. First write the given equation as equation number 1. X cube plus y cube into dx minus xy square dy is equal to 0. Mark it as equation number 1. This is in the form of, the given equation is in the form of m dx plus n dy is equal to 0. So mark it as equation number 2. So now see the first equation and second equation and compare m and n. So the m is equal to x cube plus y. We have to compare equation 1 and 2 and write m and n terms. So from equation 1 and 2, m is equal to x cube plus y cube and n is equal to minus xy square. First we have to check the equation. M is a homogeneous function. We have to check both m and n are homogeneous functions of same degree. Okay, this is the condition. So see m is equal to x cube plus y cube. So we have to write f of x comma y is equal to x cube plus y cube. So we have to apply the condition, homogeneous condition. F of tx comma ty is equal to tx the whole cube plus ty the whole cube. Is nothing but t cube into x cube plus y cube. But x cube plus y cube is nothing but f of x comma y. Therefore, t cube into f of x comma y. Therefore, x cube plus y cube is a homogeneous functions of n of degree n is equal to 3. Okay, now check n. N is equal to minus xy square. That is nothing but f of x comma y is equal to minus xy square. Apply the condition, that is f of tx comma ty is equal to minus tx into t square y square. Therefore minus into t square, it become t cube. So minus t cube xy square. Xy square is nothing but f of x comma y. So we get minus t cube into f of x comma y. Therefore n is also a homogeneous functions of degree 3. So you have to check both m and n are the homogeneous functions of same degree. Now see what's the problem is given. X cube plus y cube into dx minus xy square dy is equal to 0. First we have to rewrite the equation in terms of dy by dx. Therefore just separate. Dy by dx is equal to x cube plus y cube divided by xy square. Right. See the numerator. Numerator contains x cube plus y cube. So take x cube outside. We get x cube into 1 plus y cube by x cube divided by xy square. Now next term is cancelling x cube by x. So we get simply x square, right? The numerator contains x cube and denominator contains x. So cancel one x term. So we get x square in the numerator. Therefore the next step is x square into 1 plus y cube by x cube divided by y square. Okay, next step. X square into 1 plus y cube by x cube can be written as y by x the whole cube. Therefore x square into 1 plus y by x the whole cube divided by y square. Right. The next step. Put z is equal to y by x. We have to put z is equal to y by x. Therefore y is equal to zx. For the equation dy by dx is equal to x square into 1 plus, we have to put z is equal to y by x. So 1 plus z cube by y term is equal to zx. No, so y is equal to zx. So x square into 1 plus z cube divided by zx the whole square. So we get, see the numerator, x square into 1 plus z cube divided by x square into z square. For x square getting cancelled. So we get simply 1 plus z cube by z square. So we get the equation, third equation is dy by dx is equal to 1 plus z cube by z square. Now we know that y is equal to zx. Now we have to differentiate the term y with respect to x. We get dy by dx is equal to z plus x into dz by dx. Mark it as equation number 4. Now equating equation 3 and 4, we get 1 plus z cube by z square is equal to z plus x into dz by dx. The next step, take the z to the left hand side, we get minus z. So 1 plus z cube by z square minus z is equal to x dz by dx. So the next step is taking LCM. 1 plus z cube minus z cube by z square is equal to x into dz by dx. The next step, cancelling z cube. Plus z cube minus z cube is getting cancelled. We get 1 by z square is equal to x into dz by dx. Right. Now we have to separate the variables x term and z term separately. Now, so dx by x, in the left hand side x variables separated, dx by x is equal to, see the right hand side, z square into dz. So we have to separate the x variables and z variables separately. So we get dx by x is equal to z square into dz. Next step, we have to integrate. Integral dx by x is equal to integral z square into dz. Right. What is integration of dx by x? We get log x. Log x is equal to integration of z square, z cube by 3 plus c. Okay. The next step is taking LCM. So we get 3 log x is equal to z square plus 3c. Okay. 3, the constant become 3c. The next step is 3 log x is equal to z cube by c1. See the constant 3c. 3 is c. C is nothing but an integration constant. So after taking LCM, we get 3c. You have to rewrite the 3c as c1. c1 is nothing but a constant. We have to just rename. So 3c can be written as c1. So the next step is 3 log x is equal to z cube plus c1. Right? Next step, 3 log x is equal to, next step is we have to apply z is equal to y by x. So y cube by z cube plus c1. Next step is you have to just rewrite y cube by x cube is equal to 3 log x plus c1. Actually, c1 comes to the left hand side, it becomes minus c1. Okay, but c1 minus c1 is nothing but same because c is a integrating constant. So we have to write minus c1 as simply plus c1. So we get y cube by z cube is equal to 3 log x plus c1. That is the answer. See where 3c is equal to c1, so it is a constant. So 3 log x minus c1 is the actual term. 3 log x minus c1 is equal to y cube by z cube. For 3 log x minus c1 can be renamed as plus c1 because it is a constant. So c1 is equal to y cube by x cube. Therefore, minus c1 is the integrating constant. We have to put c1. Okay. For the solution is y cube by x cube is equal to 3 log x plus c1. Okay. See the next problem. Actually, this is a homework sum. Last class I gave the sum. Solve x cube minus 2, solve x square minus 2y square dx. Solve x square minus 2y square dx plus xy dy is equal to 0. This is a given problem. First, see the given problem is in the form of m dx plus n dy is equal to 0. So first we have to check m and n are homogeneous functions of same degree. Okay, so f of x comma y is equal to x square minus 2y square, and substitute the condition, f of tx comma ty is equal to t square x square minus 2 t square y square. Take t square outside, we get t square into x square minus 2y square. If f of tx comma ty is equal to t square into f of x comma y. And a next term n is equal to xy. So f of x comma y is equal to xy. Next step we have to apply the homogeneous condition, that is f of tx comma ty is equal to tx ty. The next step is take t into t, we get t square. So t square into xy. Therefore, f of tx comma ty is equal to t square f of x comma y. Therefore, xy is also a homogeneous function. Therefore, m and n both are homogeneous functions of same or degree. Right. Now come to the problem. The given, that is what's the problem, x square minus 2y square into dx is equal to minus xy dy. Now rewrite the given equation. Dy by dx is equal to x square minus 2y square divided by minus xy. Right. The next step, see the numerator. Numerator contains x square minus 2y square. From the numerator, take negative sign outside. So we get minus of 2y square minus x square divided by minus xy. Right. The next step is cancelling negative sign. From the numerator and the denominator, we get 2y square minus x square by xy. Next step is, see the from the numerator, take x square outside. So the new term contains 2y square minus x square by xy. So from the numerator, take x square outside. We get x square into 2y square by x square minus 1 divided by xy. Right. The next step is, see the numerator contains x square and the denominator contains x. So cancel one x term. So we get x into 2 y by x the whole square minus 1 by y. Okay. The next step, we have to substitute y by x is equal to z and y is equal to zx. So we get dy by dx is equal to x into 2z square minus 1 by zx. Right. Next step, see the numerator and denominator. So cancelling x term, we get dy by dx is equal to 2z square minus 1 by z. So mark it as equation number 1. And we know that y is equal to zx. We have to differentiate the y with respect to x. So we get dy by dx is equal to z plus x into dz by dx. Mark it as equation number 2. So from 1 and 2, both the left hand sides are equal. So we have to equating the right hand side. We get 2z square minus 1 by z is equal to z plus x dz by dx. The next step, write the z to the left hand side, we get minus z. So 2z square minus 1 by z minus z is equal to x dz by dx. The next step, taking LCM. 2z square minus 1 minus z square by z is equal to x dz by dx. The next step, 2z square minus z square becomes simply z square. So z square minus 1 by z is equal to x dz by dx. And now we have to separate the variables. X variables and z variables separate, different terms. So take x variables to the left hand side and the z variables to the right hand side. We get dx by x is equal to z by z square minus 1 into dz. So next step, you have to separate the variables x and z. And next step, now we have to integrate. So integral dx by x is equal to integral z by z square minus 1 into dz. Listen. Now consider the integral right hand side. See the right hand side integral. It contains integral dz by z square minus 1 into dz. So first we have to integrate the term separately. See, integral z dz by z square minus 1. And see the numerator. Numerator contains z. And see the denominator. It contains z square minus 1. When we differentiate the denominator, we get 2z, right? Z square minus 1. When we differentiate, we get 2z. But see the numerator, we get only z. Which term is missing? 2 is missing. Okay, when we differentiate the denominator, what's the denominator? Z square minus 1. We differentiate the denominator, we get 2z. Okay, see the numerator, which term is missing? 2 is missing. So we have to multiply and divide it by 2. So we get 1 by 2 integral 2z divided by z square in z square minus 1 into dz. And we know the formula. Integral f dash of x by f of x is equal to log f of x. So we have to apply this condition. Integral z dz by z square minus 1 is equal to 1 by 2 log of denominator. What's the denominator term? Z square minus 1. So 1 by 2 log of z square minus 1. Okay. Now see the before step. We get integral dx by x is nothing but log x is equal to, after integrating the right hand side, we get the solution 1 by 2 log of z square minus 1 plus log c. Because all the terms contains logarithm, you have to apply log in constant term also. So we get log x is equal to 1 by 2 log of z square minus 1 plus log c. Okay. The next step, log x is equal to 1 by 2 log of z square minus 1 can be written as log root of z square minus 1. Okay, we have to apply the logarithmic condition m log n is equal to log m power n. So applying this condition, so log of root z square minus 1 plus c. Next, you have to write log x minus log root z square minus 1 is equal to log c. So next condition, you have to apply log m minus log n is nothing but log m by n. So applying that rule, log x by root of z square minus 1 is equal to log c. Next step, cancelling log on both sides. So we get simply is x by root z square minus 1 is equal to c. After cancelling logarithmic term, we get x divided by root z square minus 1 is equal to c. Okay, next step, we have to put z is equal to y by x. So x divided by root y square by x square minus 1 is equal to c. Next step, x divided by, we have to applying the LCM. So we get root y square minus x square by root x square is equal to c. So see the denominator, we have to just taking the reciprocal, it becomes x into root x square, it becomes x. So x into x by root y square minus x square is equal to c. It becomes x square by root y square minus x square is equal to c. Next step, you have to just cross multiply. X square is equal to c root y square minus x square. Next step, by removing the square root. So see the right hand side, we contain the root term, square root term. So by removing the square root term, taking squares on both sides. We have to squaring on both sides. So see the left hand side is x square. So you have to squaring, we get x power 4. X power 4 is equal to, see the right hand side, c becomes c square and root y square minus x square become simply y square minus x square. The next term, y square minus x square is equal to x power 4 divided by c square. The next term, y square minus x square is equal to x power 4. 1 by c square can be written as c1 square. That is nothing but a constant. So we have to rewrite 1 by c square as c1. 1 by c is nothing but c1. So 1 by c square is c1 square. So the solution is y square minus x square is equal to x power 4 into c1 square. That's the solution. Okay girls. Okay, see the assessment problems. I gave 3 problems, same method. Okay, first sum x square minus xy dy plus y square dx is equal to 0. Solve this equation. First you have to prove m and n are both homogeneous functions of degree n, and you have to solve the problem. Same second one and third one. See the answers are given. For the first one, the answer is given y minus x log y is equal to cx. For the second one, the answer is y plus root of x square plus y square is equal to cx square. And the third one, the answer is given 1 by 2 log of x square plus y square plus tan inverse of y by x is equal to c. Okay girls. Okay students, do the assessment problems girls. Just go through the problems. Revise the last class portions. Study all the theory part. Study all the formulas, conditions girls. If you have any doubt, feel free to call me. I will clear your doubts. Okay girls. Thank you.